My talk is almost 15 or within 15 minutes, so let's start the talk. A mission of our lab. Mission is contribution to create high quality of life by applying robotics technology. So this is so in the Allied laboratory there are many research topics, but I think we can divide the topics mainly two. One of them safety and security robotics, and the other is micro robotics. So today I introduce several robots and some application of the robotics technology in our laboratory. First, that's the robot. The application is maintenance of the home and building structure. As an example of maintenance, that's a very narrow space in the above ceiling or on the floor. That's a very narrow, and human worker cannot work in that very narrow space. And the right figure shows the very dangerous situation. So in that situation, the human worker also cannot work, and it's very tough work. So we want to apply our robot to these applications. For such robots, the robot needs the ability to move in narrow space and even not only move in narrow space, but also it can manipulate object. So this is an example of motion of the robot is going into the narrow space. Here the robot has 6 legs, and it can change its pose to go into the narrow space, like this. Now this robot, we call it limb mechanism robot. So limb mechanism robot, limb means the integration of the function of the arms and legs. It can not only use legs but also arms. And it has this is an example of manipulation of the robot. Sorry. It has 6 limbs and move. I think let's move. That move, and it can find the object, and it uses the limbs like arms by grasping using the 2 limbs. Now try to grasping, and then the robot can move on its back, so it can carry a very small object. So, and it has a very symmetrical structure, so it can move very omnidirectional ability, and it has also symmetrical to up and down, and it can move and above the ceiling, like this way. The robot hook its limbs to the lattice of the ceiling, and when it goes down from the ceiling, it has a wire, and by using a winch, it can go down to the floor. And in that case, the robot only go down to the limb. Then it can start the walk on the floor. So some newspaper or such media call this robot as a spider. But actually it has only 6 limbs, so it's not a spider, but someone call it a spider robot. Soon, I think it's go down. I think. Can you wait? Then, these robots appears on the Aichi Banpak Expo. I think that's held 2005 in Japan. So it's actually the robot demonstrate in the expo. Oh, this is such spider actions. So this is a motion to go in the narrow space. The previous slide is motion that we made, predetermined the motion. So, but this is automatically adjust to the environment by checking the touch to the environment. Then robot change its shape, adapting to the environment. And the right motion is a dynamical rotational motion. So it can rotate using this way to go into a very narrow space, like this. So this is a robot that we call the mechanism robot asterisk. So next, it's another topic. We have a humanoid robot. By using this, we can help humans in daily life. So this is a movie. The human robot helps the motion moving of the wheelchair, like this. This motion is made by the researcher, but he surprised to suddenly the robot moves into. But now we want to try to this motion to safety and human and feel safe by these helping motion by human. So we are trying to develop these motions. And this is another, sorry. Sorry. Okay. This is a small robot. That's the. It has the same degree of freedom to this humanoid robot, and by operating the small robot, this humanoid has the same pose. In case the human unintentionally appears suddenly on the front of the robot, the teleoperator disturbs the motion of the small robot. Then this humanoid robot also stops. So after human removing, then the robot starts its motion. We call it the marionette system. And we also have service robots. This robot is developed by a Fujitsu company in Japan. So we developing its motion, vision and locomotion and manipulation coordination functions. And we develop these motions by using the software component, such as a vision component or a grasping component or locomotion component. So this is a movie of demonstration in the International Robot Exhibition 2009. It's held in the Tokyo. Okay, so next, this is another topic. So there are many humanoid type robots in the world, and this is a HRP2 or ASMO or Wakamal or also Asada Sensei has many humanoid robots, Akachan robot, baby robot. But we don't know how much appearance or motion is feel safe to the human, even especially in the human-robot interaction. So we have been trying to design the safety robot appearance and motion, and by using virtual reality. So it's difficult to develop new humanoid robot. It costs much money. So, but using virtual reality, we can easily change its appearance and motion. Then we can evaluate the suitable appearance and motion for human. So this is a very abstract type of humanoid. So we can change its proportion of which proportion is the best to the human. Like this way, this is in the virtual reality, the robot go through in front of the human. Then we evaluate the human impression to the humanoid motion in this virtual reality space. So, but we don't have not so good result, but we have been developing this and continuing this topic. Next is a very different topics. We also have robotics technology for micro manipulation applications. So in a micro manipulation application, our target is to manipulate cell like this, and we have a manipulator which has fingers like chopsticks. By using chopsticks, we can manipulate the object very dexterously, grasping or rotated. And so we try to manipulate small objects such as cells, like this. So left move is teleoperation by using a joystick. The fingers are made of glasses, and it can grasping I think almost 2 micrometer diameters small objects. So right hand move is by using the vision technique, the target is automatically detected, and the manipulator find it and grasp it automatically. Left hand is I think this is a crystal of some kind of crystal, I forgot. So this is another topic in micro robotics. We call it on-chip cell manipulation. I think its application is automated cloning. In the left hand, that's the cloning process in manually. The first we remove in the nuclear, then another donor is penetrated, and then fusion. It's very complex manipulation tasks. But we design a new protocol to this process. First, removing. For removing, first we cut the cells. Then we select the one. It doesn't have a nucleus. Then we couple the donor. So by using this process in the modularized chips, then we combine the chips. We make these bioplant, like a factory. It's works on the desktop size. This is the first part of the system. We must supply the cell to the system. So find the cells automatically, then the automatically sync it to the process. So right hand is the channel in the microchips. Now the cell comes down. Then next, change the branch. We control the bulb. Then we can change the destination to the cells in the microchip by controlling the fluid. I think it comes from okay. So it's almost finished. So this is a feature of our lab. We have many staff. This is a professor, right? And it's me, and there are many staffs. And we have many publication output. And especially we have many students from overseas. Currently, in 2009, 7 students from overseas, very international, Mexico, Turkey, Saudi Arabia, Thailand, Vietnam. And every year we have these guys have a PhD. I think in average every 1 year they get a PhD. And students we seek anyone who like robots or mechanisms and highly motivated and very with tough mind. And if you are interested in our laboratory, please contact me or directly Professor Tatsuo Arai. Thank you. Thank you very much.